In this video, we're talking about products of even and odd functions, and we're trying to determine if the products themselves are even or odd. So here's a quick reminder of what even and odd functions are, and I'll post a card to the video where I first introduced this. But an even function has the property that f of negative x is equal to f of x, and its graph will have symmetry about the y-axis. An odd function has the property that f of negative x is the negative of f of x, and its graph will have rotational symmetry about the origin, meaning that if you spun the graph by 180 degrees using the origin as your rotation axis, you would just get a copy of the original graph. So I have a little suite of proofs to be done here, and the first one is let f of x and g of x be even functions. Show that f of x times g of x is even. So I'm going to give a name to the product and call it h of x. And then to test the parity of h, in other words, to test whether it's even or odd, I want to evaluate it at negative x. And then we're going to check to see if it has this property or neither one of those properties. Well, h of negative x is f of negative x, g of negative x. But f is an even function by assumption. So f of negative x is equal to f of x. G is also even, so g of negative x is equal to g of x. And f of x times g of x, well, that's the original function h. So I've just showed that h of negative x is equal to h of x. Therefore, h of x, in other words, the product of f and g, is also an even function. I want to look at just a quick example here. So a product of even functions is even. So for example, y equals x squared cosine x should be even because x squared is an even function and the cosine function is even as well. And I'll post a card to the video where I showed that. So let's just take a quick look at the graph. There's the graph of x squared cosine x, and I can see it does have that reflection symmetry about the y-axis. All right, next. Let f of x and g of x be odd functions. That means they have this property, f of negative x is negative f of x. Show that their product is even. Same strategy here. Give the product a name. To test the parity of that product, you would evaluate it at negative x. But f and g are both odd functions, which means I get negative f of x and negative g of x out of this. And I can pull those two factors of negative 1 out in front, and I get a positive 1. And I arrive at f of x, g of x, which is my original function h of x. So I have h of negative x equals h of x. Therefore, h of x, which is the product of f and g, is even. So let's look at a quick example of a function that's a product of two odd functions. So I'm going to look at x cubed sine x. X cubed is an odd function. The sine function is an odd function. Let's see what the graph looks like. Again, I see that reflection symmetry about the y-axis, which is what I expect to see for an even function. All right, finally, let f be even and g be odd. Show that their product is odd. Same strategy. Evaluate the product at negative x. And I said f of x is even, which means f of negative x is equal to f of x. But g of x is odd, which means g of negative x is negative g of x. I have one factor of negative 1 this time, and I can pull that out in front. And I get negative f of x g of x, which is the negative of h of x. So h of negative x turned out to be the negative of h of x. That's exactly the definition of an odd function. So h of x is odd. Quick example of this, I could look at the graph of x cubed cosine x. That's a product of an odd function x cubed and an even function cosine x. So let's bring in a picture and see what it looks like. And as we expected, this graph has rotational symmetry about the origin, where if you rotated it 180 degrees, it would land on top of the original graph. That's our classic odd symmetry. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.